It's been great so far. Really happy to be here. Thanks to Natasha and the organizers. Thanks to everyone for sticking around. I know it's been a long day. So I have a lot to cover, so I'm going to jump right in. The theme of this talk is basically about how we're constantly adapting to change as software developers. Our code and our code is ever changing. We're constantly adding features, removing features, refactoring. No code base is stagnant, at least not one that's being worked on. So I work at a company called PlanGrid. The best way to think about PlanGrid is that it's like GitHub or Xcode or something like that, but for construction field workers. So things like on GitHub where you open an issue to report a bug. Basically, buildings have bugs too. And there are a lot of similarities actually between construction and software. And it all really ties into this idea of adapting to change, because just like in software projects, when things go wrong in construction as well. We have many different components that we need to connect together. Maybe you write this model layer, someone writes this UI layer, and then you have to connect them together, and sometimes it doesn't always work out. We have a lot of different users that we have to accommodate through different accessibility features. Sometimes we forget to do this on iOS, or we're lazy and we don't. And those users have a worse experience. We have to work with multiple teams. So it's not just our client teams, if you're on iOS and Android, coordinating a new feature or a product, but also with the server teams. And sometimes things get lost in translation. As Kate was saying earlier, it helps to talk to people sometimes. And then sometimes we design things where it sounds really great on paper. It's like this excellent idea, but then you actually build the thing, and it doesn't turn out like you thought it would. Sometimes you'll have user privacy issues to deal with, or just usability issues. You build something that you think is great as a developer, and then your users are like, I don't want to use this. And then a lot of the time, what we're actually dealing with is just like really bad architecture decisions. We move really fast. We want to ship a product. We want to ship a new feature. But the way that we've constructed our code backs us into a corner, and we can't move without either refactoring or just hacking things around. So we're constantly in this this like designing and building and prototyping and verifying phase. But ultimately, that means we are just constantly adapting to changes. Requirements change. You ship a new feature and something goes wrong, and we're just constantly adapting to all kinds of different inputs. And it usually manifests, you're writing some code, and like everything is awesome, you're like totally in the zone, but then you hit this wall. And not just because the Swift compiler is slow. This new feature you need to add, there's no way to add it in your current system. Maybe your models are like hard-coded to your views. You don't have a good separation. You're just like totally stuck. And again, like you're constantly in these situations where you just have to hack something up really dirty and leave a bunch of comments and a bunch of to-dos and say, oh, I'm going to come back to this later and clean things up later. I'll refactor it after this next release. And of course, that never happens. So how can we prevent these kinds of situations? The thing is, we really can't, but we can try. We can make things, a little bit less terrible, and by organizing our code base in a way that allows us to keep things modular and maintainable in different ways. And so you may reach for one of these patterns, and we've seen people talk about these a lot today. And it doesn't really matter like which one you choose. all of these patterns have pros and cons. They all solve different problems, or sometimes they solve the same problems in different ways, and it comes down to a lot of opinions, a lot of preferences, but the main thing that all these things are trying to get to is a separation of concerns and a clear data flow. That's ultimately what the goals are with each of these things. So if none of these really fit with what you like, just choose some like random Roman numerals and go with that. Okay, so what they're all, the underlying principles here are really the solid design principles, which is the only acronym that you should remember. This typically refers to like object-oriented programming design, which if you're doing iOS, you're still involved in OO because we have to use UIKit and Apple's other frameworks. But these ideas can apply to functional programming as well. So this is what SOLID stands for, and we're going to jump through each of these and look at some examples about how these ideas can inform the code that we write and make our code more malleable and maintainable. So the single responsibility principle says that any type you create should only have one reason to change. So whether that's a class or a view controller or a struct, anything that you're writing, you should really focus on having a single responsibility. So we could write things like this. We have this like image downloader class, but it's like caching stuff in memory, and it's also like managing files. It's also like doing networking, and you could have this some kind of function like this that's just like, oh, give me this image. So it's kind of opaque, but really this thing is like doing all these different things. It's also hard-coded to download and cache images. We could write something a little bit better by decomposing these components and then recomposing them later. So here we could extract this downloader class, have all of our networking code in there, and this thing, optionally, it could be generic over parameter T. So then you could have specific downloaders for different types of data. Same with this cache we can extract, and then later we can have this some other class. You can name it whatever you like. So we'll call this like our data provider, which will own a downloader and own a cache. So we'll decompose this God class that's doing way too many things and then recompose it in this way. And so the responsibility of this data provider would be to just do the coordination between the components that it owns. So perhaps it would check the cache first, return that item if it's there, and then otherwise go download it. And we can have a nicer API here that kind of leaves these details kind of opaque to the clients. This also makes things easily testable because now you can test each component individually. This also works for functions. So maybe you have this like mega function here, like on UI image, we're gonna like crop, filter, maybe transform or like rotate this image and then convert it to PNG data, and then maybe save that to disk or do something else. This is not very flexible. You may write this API where everything's optional, and then like in the method you'll check like, oh, if it's not nil, then I'll do this thing. But it creates this kind of code that's like not easy to change later. So one thing we could do is to decompose this into separate functions. So we'll have a separate, crop function, a separate transform, separate filter, and this way we can, chain these together nicely. It looks a lot better, but more importantly, later when requirements change, let's say this is some kind of photo editing app, maybe you're going to display photos to the user that have already been filtered, but you just need to crop them. Well, now you can extract just that one function and only crop that image, or you can reorder these. It allows you to take these little pieces of your code and move them around more efficiently. as features in your app change. This next idea, the open and closed principle, says that we want our libraries, our frameworks, our different components to be open for extension but closed for modification. So how can we change behavior without actually modifying the source of a type? One way is to subclass, which is not my favorite suggestion here, but unfortunately we do have to do this in UIKit and with lots of Apple's APIs, things like NS operation. A better way when we're designing our own types is to inject these dependencies, and we can do that with closures or protocols. So one common pattern in Objective-C APIs and Apple's frameworks is this kind of like configuration, this using an enum as a configuration. And Objective-C, this kind of makes sense because Objective-C is not as expressive. It's much more limited. So suppose we have, we're building like a messaging app like iMessage, and we want to show timestamps above the message bubbles. So we could model this as an enum. Maybe you're building this kind of framework, and so maybe you want to, and sometimes you want to display messages above every single message, or you want to display timestamps above every message bubble. Maybe you just want to do it every other, maybe every 5. And so we could write some kind of code like this, and then maybe this view controller just has a property that we set. But the thing is, this is not very malleable. When you want to do something more, when you want to do something totally different, like let's say you only want to show a timestamp if it's a new day. So like every 24 hours you would have like a timestamp and all the messages under that for that day. You can't really do that in this situation, and you always end up with hideous code like this that's extremely hard to maintain, where you constantly have these switch statements everywhere. If you add a new case or remove a case, you have to update all of these switch statements everywhere you have them in your code base. A more flexible and what actually turns out to be a much simpler design is to use a configuration object like this here, so we can have this like timestamp config object where timestamp is actually a closure. So the client just provides a function that it receives an index path, and then it'll return a date for the timestamp. This is also more extensible in the sense that then you could have other elements here that you want to change. So if you want to configure some timestamps to have certain text colors or certain font, then you can do that here, and then we can have this function that will just apply this configuration to the view controller. And you'll have much cleaner code. You don't have to worry about extending this enum, adding, removing cases, and all of those 4 cases in that enum, we can still model however we want with this function here. You can do it. You can always return a date, or you could return a date for every 5th message, whatever you like. The next property, or the next principle, is Liskov substitution. So this says that we should, any type in our app should be replaceable with instances of their subtypes without altering the correctness of the program. So if you have a hierarchy of protocols and a function that receives a protocol, if you pass a child protocol to that function, correctness should not change. Your program should still work. Same with classes and subclasses. Any subtype should not change behavior. And this is a huge code smell. This is what you see probably more often in Objective-C, but it still happens in Swift, where you start checking the class type of something. So again, let's say we're building iMessage. We have like a message superclass. We have our text message type and a photo message type. And somewhere in our code base, we have to handle how we display the text, how we display the photo. And you could maybe do something like this, where you're checking the type of that model. And then you'll have this fatal error for like unexpected types just to catch maybe potential bugs, right? But this is awful because that means now if you add a video message type here, your program is now incorrect. You're going to crash. So one way that we can rework this code and make it more adaptable to change is we can define, let's say, an enum, or this could also be a struct for like the actual message content, the types of your message. We could have this protocol that provides that content, and then each message type can just provide its own content. So let's say like the text message, you would have like a text property that's a string, etc. And then you can just use that. The good thing about modeling in this way is that now any new message type that you have to add, it just needs to conform to this protocol, provide data, and the rest of the system is just talking to that protocol, and everything will just kind of work downstream instead of getting caught up in like fixing all these fatal errors where you're changing classes. The next principle is interface segregation. So UIKit, in my opinion, gets this wrong in a lot of cases. If you think about the table view data source protocol, for example, it's this giant protocol, has a bunch of unrelated methods. A better way to design this when we're designing our own data source and delegate types is to really split these up into their specific semantic groupings. So we could have our standard like data source where we get our table cell, the number of sections and the number of rows, and then the editing methods could be in their own protocol. So when you're designing your classes, keep this in mind. Even with structs, your protocol hierarchies, if functions or computed properties or whatever are not related, maybe they should be in a separate protocol. The last principle here is dependency inversion. Again, this is about writing against interfaces and not concrete types. It's about decoupling, and we can do that via protocols and dependency injection. And here we're combining a lot of different ideas. Lots of apps have to have this notion of a session manager or a current user. Usually this is pervasive about around the code base, and most of your view controllers are probably accessing this like current session or whatever directly. It hinders your code base. Like if you are a single user app, maybe later you need to support multiple users, and then you run into a whole slew of issues where you have to refactor the entire world. If you start with something like this, that kind of refactoring that has to come later is going to be much easier to change. So first of all, this view controller can only talk to this protocol. It doesn't know the explicit type. But we can also inject this in the initializer, and give it the concrete like shared manager that we have. And then from here, you know, this view controller will just be using self.session manager. In this way, this view controller is testable. We can inject a fake type in a unit test through this protocol. But in our actual code base, we don't have to deal with like the transitive dependency issues where view controller A all the way down to view controller D, if you have to like pass these dependencies down, because we can inject it here, and later we can adapt to changes as they come if we actually need to start passing these components down. But ultimately, this is about decoupling components, because the more intertwined your code base is, the more cognitive load there is. It's harder to understand if one class or view controller, whatever type you have, depends on 6 other types that you have to understand in order to understand that original type. It's much harder to maintain and much harder to just understand in general. So the last thing I want to talk about is clarity and how we can write code that's more clear, and Swift makes this really easy with its lightweight types like enums and structs and protocols. So if we look at this example, let's say we're drawing line graphs, maybe we're modeling like a pedometer app or the stocks app. So we can get like a couple points, we can find the slope, and there are 4 cases that we need to check here. A vertical line, the slope is undefined, and then we have horizontal, positive, and negative. So we could write some code like this where we're just checking all these different cases. Maybe we add some comments here to explain what's happening. You know, if the slope is not a number, that means it's undefined, and we'll handle the special case. But really, it'd be much better if in this component we just write a few extensions for this specific domain. So on the floating point protocol, we could redefine isNon and is0 as is undefined and is horizontal. Same thing for positive and negative. And then we can write code like this, where we remove the comments, and this code just reads like a sentence. We can say, oh, if the slope is horizontal, we'll do this thing. If it's positive, we'll do this other thing. Maybe we're going to color the line in a certain way or draw it differently. This is a snippet of code from an open source library that provides a dynamic collection view layout that's similar to iMessage, you know, where the bubbles kind of float around. So we can look at this code, and it's you know, there's nothing wrong with this code. We might say it's Swifty. It's using, you know, filter and map, and all these closures are chained, and there's some comments there explaining what's happening. But it actually takes quite a while to kind of dissect what's happening here, and we can restructure this in a much better way. Again, we can write some extensions on like attachment behavior and our dynamic animator to make the code that follows in this method much more readable. So we're still using all of the same functions as before. We're still doing the exact same thing. We still have our map and our filter, but now we can clearly see, okay, we get these index paths, we get these attachment behaviors from the animator, we're going to filter those, and then, okay, so this method is actually, you know, just filtering some dynamic behaviors and returning those, where in this method it's like, well, I don't really know exactly what this is doing just by reading it. And so we can restructure in this way that's much easier to read, much easier to maintain. So I think one takeaway here is like anytime you start to write a comment, think about if you could just write code instead. Can you just extract these 5 lines into a new function or into a computed property and remove the comments? Because often the comments that you write are going to get stale because someone else on your team is going to come and change that code and ignore the comments because no one reads comments, right? And so here we can see that this stale comment, you know, we're going to show this if the user has permissions, but clearly we are negating that here. So you write these comments, then the code and the comments get out of sync, and it's just kind of a mess. If we can write our code in a way that's readable, that we don't need these comments, again, it's easier to maintain, easier to change. So there are still valid uses for comments. I think anything that's exceptional or non-obvious. Again, if we are building an iMessage, a messaging app, perhaps we want to specifically use classes. You know, structs are very popular in Swift. We want to focus on value types a lot of the time. But maybe we intentionally want to use reference types for performance reasons. So last thing here, like, so I think this is really what, you know, the things we need to focus on. It doesn't matter if you're using Viper or Flux or MVC. If you keep your components small and simple, write code, not comments, keep your components separated, and try to avoid any kind of unnecessary complexity. Over time, as you have to adapt to change, your code base will be easier to modify and maintain. And so I'll leave you with this. This is a tweet from Slava, and I completely agree. I also think that when programmers get bored, we tend to make easy things way too complicated, right? So Slava on Twitter, he says, so he's a engineer on the Swift compiler team. A large portion of every code base is just programmers showing off, creating unnecessary complexity to prove how smart they are. So don't be that guy. And that's all I've got.